Welcome to G Fun Facts Online. From the pyramids of Giza to cities that seem to rise from the desert overnight, humanity has always been driven to build big. Today, we call these endeavors megaprojects, ventures so large, so complex, and so expensive, they reshape the world. We often marvel at the engineering, the physics, and the design. But behind every modern monument is a hidden masterpiece of organization, a symphony of movement and timing that makes it all possible. Today, we're pulling back the curtain on the single most critical discipline that determines whether a billion-dollar dream becomes a reality or a ruin: logistics. Let's start by looking back. To understand the challenges of today, we need to appreciate the logistical genius of the past. Take the Great Pyramid of Giza, built around 2500 BC. It's made of 2.3 million stone blocks, weighing a combined 6 million tons. For over 800 years, it was the tallest man-made structure on Earth. How did they do it without modern machinery? It was a logistical masterclass. The project started with strategic sourcing. Most of the limestone came from quarries right on the Giza Plateau, minimizing travel distance. But the fine, white-casing limestone was brought from across the Nile River. The massive granite blocks for the King's Chamber, some weighing up to 80 tons, were floated on barges from Aswan, over 800 kilometers away. Once on land, a system of ramps, likely lubricated with water, was used to haul the stones into place. This required a massive, highly organized workforce. And contrary to popular belief, these weren't slaves. Archaeological evidence points to skilled, paid laborers living in a well-organized city. Their support system was a logistical marvel in itself, responsible for procuring and distributing immense quantities of food, water, and tools to sustain a workforce estimated at 40,000 people. Fast forward to the Great Wall of China. Stretching for thousands of miles over brutal terrain, its construction was a lesson in adapting to the environment. Instead of transporting materials over vast distances, builders used what was available locally, rammed earth on the plains and stone in the mountains. This localized approach was a logistical necessity, but the project still required a massive supply chain to support the millions of soldiers and laborers. Granaries were built along the wall, and a complex network of carts and animals moved food, water, and weapons to the most remote construction sites. Then there's the Inca Empire's incredible road system, the Kapaknyan. This network spanned over 40,000 kilometers, connecting a vast and challenging empire through mountains and jungles. The Incas built suspension bridges from woven grass and carved stairways directly into mountainsides. This lifeline was built and maintained by a state-organized labor system called the Mita. These ancient projects, while different in purpose, were all triumphs of logistics. They prove that managing resources, labor, and geography has always been the foundation of monumental construction. The tools have changed, but the principles remain. But the megaprojects of the 21st century operate on a level of complexity our ancestors could never have imagined. Today, a megaproject is formally defined as a venture costing at least $1 billion, taking years to build, and involving a web of public and private stakeholders. They are defined by several key characteristics. First, immense scale and cost. China's Belt and Road Initiative, for example, has an estimated investment of over $8 trillion. Second, unprecedented complexity. A new international airport isn't just a building. It's an integration of air traffic control, baggage handling systems, retail centers, and ground transport networks. A mistake in one system can cause a cascade of failures. They also have extended timelines, often spanning decades, which exposes them to economic downturns and political instability. And unlike the top-down projects of the ancient world, modern projects involve a multitude of stakeholders: governments, investors, corporations, and local communities, all with competing interests. This creates a logistical gauntlet. Let's break down the three biggest challenges. First is the global supply chain. A single project today might source materials and components from dozens of countries. While this provides access to specialized goods, it also creates a fragile house of cards. The COVID-19 pandemic was a brutal lesson in this, as a disruption in one part of the world caused material shortages and massive delays globally. The just-in-time delivery model, popular in manufacturing, is incredibly risky here. A delay in one critical component can bring a multi-billion-dollar project to a grinding halt. The second challenge is mobilizing a global workforce. Megaprojects require a huge number of highly specialized workers, from engineers to laborers. Recruiting them from all over the world is a massive undertaking. Then, you have to transport thousands of people to what is often a remote, inhospitable location. Once they're on site, you have to house, feed, and care for them. This often means building entire temporary cities in the middle of nowhere, complete with housing, canteens, and medical facilities. Sustaining these remote communities is a monumental logistical task in itself. The third challenge is moving the giants of construction, the monumental machinery. Modern projects are built with some of the largest machines on Earth. Tunnel boring machines that chew through mountains, or cranes that can lift thousands of tons. Transporting this equipment is a project within the project. These machines are disassembled at the factory, with every part meticulously documented. The oversized components are then transported by road, rail, or sea, requiring special permits, police escorts, and carefully planned routes to avoid obstacles like bridges and power lines. Once on site, reassembly can take weeks or even months. So how do we tame this beast of complexity? The answer is technology. At the heart of it all is building information modeling, or BIM. Think of it as creating a digital twin of the entire project before a single shovel hits the ground. This 3D model contains every piece of information, from architectural plans to electrical wiring. Using BIM, teams can identify potential clashes between systems, like a pipe running through a structural beam, and fix them virtually, saving enormous amounts of time and money on rework. It allows for a collaborative platform where everyone is literally on the same page. Then we have GPS and telematics, the all-seeing eye of the modern construction site. By equipping vehicles, equipment, and even workers with trackers, managers get a real-time, complete picture of everything happening. This helps optimize delivery routes, track expensive equipment to make sure it's not sitting idle, and even prevent theft through geofencing, which alerts managers if an asset leaves a designated area. Drones have become the indispensable eye in the sky. They can survey and map a vast project site in a fraction of the time it would take on the ground. They monitor construction progress, providing a visual record that helps managers spot issues early. They also enhance safety by inspecting hard-to-reach or hazardous areas without putting workers at risk. Tying it all together is the Internet of Things, or IoT. This is the network of interconnected devices and sensors that creates a web of intelligence. By embedding IoT sensors in materials, shipping containers, and equipment, managers can track the location and condition of everything in the supply chain in real time. This allows for proactive management, reducing the risk of delays, damage, and loss. And if IoT is the nervous system, then artificial intelligence and machine learning are the brains. AI algorithms analyze the colossal amounts of data generated by BIM, GPS, and IoT to find patterns and make predictions. AI can forecast material demand with incredible accuracy, optimize transport routes, and even predict supply chain disruptions, like those caused by extreme weather. It also enables predictive maintenance, analyzing data from equipment sensors to identify potential failures before they happen, preventing costly breakdowns. But even with all this technology, megaprojects are still a minefield of risks. Risk management is about more than just a checklist. It's a proactive strategy. You have supply chain risks, financial risks like cost overruns, political risks from changing governments, and environmental risks. A huge part of navigating this minefield today is sustainability. This is no longer a fringe concept. It's central to modern project management. Sustainable logistics means adopting a holistic approach. It includes green procurement, which means sourcing materials from sustainable suppliers. It means energy-efficient transportation, choosing rail or sea over road where possible. It means embracing the circular economy, designing projects to minimize waste and to reuse or recycle materials. And it means social responsibility, ensuring fair labor practices and minimizing disruption to local communities. To see how this all plays out in the real world, let's look at a couple of examples. A major success story is the Dubai Metro. This 75-kilometer-long driverless railway was completed in just 49 months, on time and within budget, a genuine rarity. The key was integrated project management. A single, empowered authority had clear control and fostered a culture of intense collaboration. They made extensive use of technology like BIM to optimize every stage. On the other side of the coin, we have Boston's Big Dig, a cautionary tale. This project to reroute a major highway underground was plagued by problems. The final cost ballooned from an estimated $2.8 billion to over $14.6 billion. Its failure can be traced to inadequate planning, a lack of clear leadership, and a failure to manage the project's immense risks and complexity in a dense urban environment. So what does the future hold? The era of the megaproject is far from over. As our world becomes more populated and urbanized, the demand for new infrastructure will only grow. Future projects will be even more ambitious, with a greater emphasis on sustainability and resilience to challenges like climate change. AI, robotics, and automation will become even more integrated into their construction and operation. But the fundamental challenges will remain. The success of tomorrow's monuments will still hinge on the human factors: strong leadership, effective collaboration, and a relentless focus on planning and risk management. The monumental constructions of our time are more than just steel and concrete. They are the physical embodiment of our collective aspirations. They reflect our desire to connect, to innovate, and to build a better world. The logistical challenge is immense, but as history shows, when we have a grand enough vision, humanity has always found a way to build big. Thanks for listening to G Fun Facts Online.